Solve the following equations by the method of completing the square. I'll start with case A. 3x squared plus 12x minus 18 is equal to 0. The procedure for completing the square is always the same. Look at the leading term. The coefficient of the leading term is 3. Factor this coefficient from the first two terms. That would give you 3 times x squared plus 4x, and then you have a minus 18 is equal to 0. Now inside the bracket we would add the square of half of the coefficient of x. The coefficient of x is 4. Divided that by 2, you will get 2, and square it. That gives you 4. Inside the bracket, add this 4 and subtract it, and close the bracket. Then you have minus 18 equal to 0. Since 4 minus 4 is equal to 0, we have not changed the left hand side. It looks different, but upon simplification it becomes the same left hand side as we had here. Now the advantage of adding the 4 and minus 4 is that the first 3 terms inside the bracket give us a complete square. In fact, instead of these 3 terms, we will have x plus 2 squared. We also have a minus 4 that I include, and then outside of the bracket we have minus 18. Now our job is to isolate x plus 2 squared, and then after that we can find x plus 2 and afterwards x. To isolate x plus 2 squared now, multiply 3 into this bracket. You will get 3 times x plus 2 squared minus 12, and you also have a minus 18. That gives you 0. Minus 12 minus 18, that's minus 30. And if you move this to the other side, you would have 3 times x plus 2 squared is equal to plus 30. You can divide both sides by a 3 to get x plus 2 squared is equal to 10. That means that x plus 2 is equal to root 10, or x plus 2 is equal to minus root 10. Now x plus 2 equal to root 10 would tell us that x is minus 2 plus root 10. And x plus 2 is equal to minus root 10 would tell us that x is equal to minus 2 minus root 10. As you can see, our original quadratic equation was reduced to 2 linear equations, which are these. And each one of these linear equations was solved to give us the 2 possible roots. Let's now start with the second example. B x squared plus 3x minus 4 is equal to 0. In this case, the coefficient of x squared is 1. So we don't have to factor the coefficient of x squared. It will not affect the expression. The coefficient of x is 3. Divide that by 2, you get 3 by 2, and square it. You will get 9 by 4. On the left hand side, after 3x, add 9 by 4 and subtract 9 by 4. which will not affect the quantity on the left hand side. Now add a minus 4, which existed in the original equation, and then you're going to have that equal to 0. The first 3 term would give you a complete square, which is x plus 3 by 2 squared. You can take the other 2 terms to the right hand side, and you would have 4 plus 9 by 4. The right hand side can be simplified, and that by taking the common denominator, and that gives us 16 over 4 plus 9 by 4. So altogether we would have x plus 3 by 2 squared is equal to 25 over 4, which is actually 5 over 2 squared. That tells us that x plus 3 by 2 is equal to 5 by 2, or x plus 3 by 2 is equal to minus 5 by 2. Once again, we are dealing with 2 linear equations. The first linear equation, if solved, would give us x to be equal to 5 by 2 minus 3 by 2, which is 1. And the second equation would give us x to be equal to minus 3 by 2 minus 5 by 2, and that's minus 8 by 2, which is minus 4. So at the end of the day, we know that the roots are either 1 or minus 4. Let's now look at the third question. Px squared plus 2qx plus r is equal to 0. This is very similar to the general equation, which is ax squared plus bx plus c is equal to 0. However, because of the difference in the way that the coefficient of x is shown, in this case the existence of the coefficient of 2, and in this case just a b, we will see that the final quadratic formula will have a different appearance. One would say that in the case of this equation, the quadratic formula would look simpler. Let's now approach solving this equation. We factor the coefficient of x squared from the first 2 terms. That would give us p times x squared plus 2q over p x, and then a plus r outside the bracket equal to 0. Now the coefficient of x in our case is 2q over p. Divide the coefficient of x by a 2, and you would get q divided by p, and square it. Q over p squared. Add this quantity and subtract it from inside the bracket. You would obtain p times x squared plus 2q over p x plus q by p squared minus q by p squared plus r is equal to 0. The first 3 terms inside the bracket would give you a complete square. You would have p times x plus q over p squared. Then you also have a q over p squared, bracket closed, plus r, which is outside the bracket, equal to 0. Now our job would be to isolate x plus p q over p squared, and then take the root and then isolate x. Let's first open the bracket. We would have p times x plus q over p squared minus p times q over p squared, and then plus r equal to 0. We take these two terms, which are indeed constants, because p, q, and r are constants, to the other side. We would have p times x plus q over p squared is equal to p times q over p squared minus r. This can be simplified in the following way. This is equal to p times q squared over p squared minus r, which is equal to q squared over p minus r. Now let's divide both sides of this equation by p to eliminate this p from the left hand side. We would get x plus q over p squared is equal to 1 by p times q squared over p minus r, which we can simplify by adding the two terms inside the bracket. It would be q squared minus pr over p, and then multiplying the numerators and the denominators to get q squared minus pr over p squared. Now we can take the root of both sides of this equation. This would lead to x plus q over p being equal to root q squared minus pr over p squared, or x plus q over p being equal to minus root q squared minus pr over p squared. We can solve both of these equations in the following way. Take the q over p in the first equation to the other side and split the root to the numerator and the denominator on the right hand side, and you would get x is equal to minus q by p plus root q squared minus pr over the absolute value of p. And on the right hand side you would get, in the same way, minus q by p minus root q squared minus pr over the absolute value of p. You can write these two solutions in one form as x to be minus q by p plus and minus root q squared minus pr over the absolute value of p. Because of the plus and minus sign here, we can ignore the absolute value. You may want to think about that for a moment and write the solution as minus q by p plus and minus root q squared minus pr over p, which can be combined to minus q plus and minus root q squared minus pr over p. These two solutions would constitute the solutions to the original equation. To summarize, the solutions of p x squared plus 2qx plus r equal to 0 are minus q plus and minus root q squared minus pr over p. You may pay attention that these solutions are very similar to the solutions in the quadratic formula. However, they look a bit simpler because the coefficients of 2 and 4, which are in the original quadratic formula, do not exist here. Sometimes people prefer to work with these form of the quadratic formula rather than the original one.